Yeah, we're showing our CT007T thermal neutron detectors. They've been running for the last 20 hours or so, just recording cosmic ray neutrons. And all three of them are reading about the same thing. They're reading about 1.2 counts per minute. And what we'll do now is we'll put one of them in polyethylene pellets as a moderator. That should increase the counts of thermal neutrons because the polyethylene will thermalize the fast neutrons. And we'll put another one into borax, and that should decrease the count rates because the borax will absorb thermal neutrons. And we'll leave the third one out as a control. In the past, we've just buried the whole unit in the moderator or the absorber, but today we'll take the back off and just put the sensor in it. And with the reason we made the sensor so that we can take it out and take it away from the main unit is so that it could be wrapped in lead. That's for people who want to use it with a fuser, for example, where there is just enormous X-ray fields, and that will get the detector glowing and will swamp it. The neutron sensor is pretty much blind to regular gamma rays, but like these very, very high X-ray fields will get them. Very high X-ray fields will get the scintillator glowing, and we'll put lots of spurious counts on it. So if you're using it near a fuser or anywhere there is a huge X-ray field, you'll want to wrap the actual sensor in lead to take that out. So the first one will go into polyethylene pellets as a moderator. So we could use wax or anything that has lots of hydrogen in it would be a good moderator. Usually having it near a person's body already does some moderation because of lots of water in people. Just cover it. That's the one in the moderator. And the next one will go into borax, which has boron in it, which is a great thermal neutron absorber. And that should slow down reduce the neutron count. It should eat up all the thermal neutrons. Okay, and the third one is this left as a control, and we'll leave these running for overnight, another 12 hours or so, and see how the count rate changed on all of those phones. Cut. Yeah, so we let our neutron detectors run for a couple of days. This is the bare one that just was out in the air, and it is consistently measured around 1.2 counts per minute neutrons. And yeah, so these ran for about a couple of days. And the next one here, that's the one we stuck in polyethylene pellets, moderator. And before we stuck it in, that's around here when we stuck it into the moderator. Before that, we had an average of maybe 1.2 counts per minute. And after we stuck it in the moderator here, it went up to about 1.6. So that's a 30 or 40% increase in thermal neutrons due to the moderator. Finally, we stuck it into the borax. It's pretty obvious when we did that. Again, before we stuck it in there, we were reading about 1.2 counts per minute in just in the air, and then after sticking it in the borax in the absorber, probably around 0.1 count per minute is the average, 0.1, 0.15, thereabouts. So what that tells us is that we are actually seeing neutrons in the bare and the polyethylene moderated neutron detectors, because the borax will only take out the neutrons. It won't take out anything else that we might be seeing. So by being able to knock down our count rate to almost zero means that we were seeing actual thermal neutrons before. We'll stop this video here, and in a couple of days or so I'll make a part 2 of this, and we'll talk about how to interpret those numbers.